Okay, hi. So in this part of the video, we are going to prepare the items that are required for us to wire up an LED to the Raspberry Pi. Now, the first thing that we require is the RPi pinouts. The RPi pinouts is a diagram of what each pin on the Raspberry Pi is actually meant to be used for. So certain pins on the Raspberry Pi are used for GPIO, and certain pins are ground, certain pins are 5 volts. So we need that diagram. In the later part of this video, we'll start to go through those pinouts that are necessary for us. The second item that we require is a port expander. This will connect, it's a ribbon cable that connects from the Raspberry Pi to the breadboard. Now, the port expander is very useful because it has got labels that can be clearly seen on the breadboard itself. The third item that we require is a light emitting diode, or LED. You can pick any color that you like. I'm using the red color one, and we just need one of that. Now the fourth item that we require is a breadboard, as shown. The fifth item we require are jumper wires, male to female jumper wires. And the last item that we require is a 220 ohm resistor. Now the color code on the resistor will be shown as red for 2, red for 2, and brown for 0, which is the multiplier. Okay, so we're not going through the resistor color code in detail here, but you can just take it as it is. So it should be a red, red, brown, 220 ohm resistor. Now get a Raspberry Pi and prepare the ports to be connected to the port expander. Those are the ports that we'll be using. Get a breadboard with the port expander fitted in nicely as shown. Connect the other side of the ribbon cable to the Raspberry Pi as shown. Now, before we start actually wiring up the circuit, usually we will refer to some assistance or some diagram for us to help us out. Now, this is one example of that, where I've created a wiring diagram. Even before we start wiring, we got to have a bit of understanding on how this breadboard works and how does current flow through this towards the LED. Now, like all of us know, a light emitting diode emits light. So the goal of this entire part is just to turn on the LED and turn off the LED. Now, when you want to turn on and turn off the LED, it works like a switch. So the control will be coming through this port here, a GPIO port, general purpose input output. Now this port is actually a port on the Raspberry Pi, which we can program it in the later part to either be on the high or on the low, or in other words, in the on or in the off state. So we can create a state value for this GPIO23 here. Now, a bit of breadboard basics. So when this port is turned on, what happens is there will be a flow of current, right? So let me start marking this. There will be a flow of current from here to here on this line. Now the breadboard actually works like this. In the middle part of the breadboard here, they're all connected vertically. That means your breadboard is connected like this in one row, connected like this in one row. So if you were to put two wires into either of these holes, the current will start to flow through this hole and out the other hole. So if you were to put a wire here on this hole, and then we take out a wire here, the current will actually flow through. Now let's look at another illustration here. I'll change the color of the pen. Let's use yellow. Okay, so similarly, if I was to put a wire here, yeah, let's say I put a wire here, the wire goes to this hole, and then the wire comes out of this hole, yeah, the current will flow through. Now if I was to put a wire here, and then I tried to connect a wire on the left of it, there is no connection between these two lines here. There is no connection between these two lines. This and this are not connected. These two, yeah, they are not connected. Okay, so in the breadboard, it acts like a short circuit wire on the vertical lines for these two rows. Yeah. Now, the second thing to note is that we've got a big gap here in the center. So the verticals actually start here and then they stop here. So the current actually just flows from here to here. If you put a wire here, you can tap the same current on that point. It will not carry on from here to here. There's a break. Alright, it will not carry on from there to there. There's a break in between these 2 points. Yeah. So that's the principle of the breadboard. Yeah. So we have gone through the center of the breadboard. In the later part, we will go through this top part because we're not using it yet, and this bottom part. They work differently. Okay, they work differently compared to the others. Okay, so I'm going to erase all ink on slide. Okay, so now let's go through that idea on how current actually flows out of GPIO 23. Okay, so current flows out. Whenever we activate this GPIO, we turn it on, current flows out. Since it's a wire, it goes out this way. It detects another wire here, so this wire will bring the current all the way towards this point, and it realizes that it can go this way because there is a connection. And then it realizes there's a resistor, so this will limit our current here. And then once it limits the current, it will reach here. Yeah, your current will go through the resistor, and it realizes there's a connection to the positive side of the LED because the current is flowing from here. You must go through the positive, and then it goes through the LED, comes out to the other leg, and since there's a connection here, it goes down and it follows the black wire down, and it realizes that there's a ground. Okay, so this is what we call a closed circuit. A closed circuit, yeah. So we have a closed circuit, and current can actually flow through in one loop, and therefore the LED can either turn on or off depending on how we control GPIO 23 in the later part. So now let's start off by wiring this circuit on the breadboard itself. So I'm going to show you a physical demonstration, and in the later video we're going to start programming it. So once you have connected the circuit, it will look something like this on your breadboard.